Welcome dear students to this session. Today we are going to discuss from class 9 mathematics book chapter 6 lines and angles part 3. Before going to discuss the lessons to be taught today, let's recapitulate what we have learnt in the last session. Here we learnt about some axioms. If rays stands on a line, then the sum of two adjacent angles so formed is 180 degree. And the second axiom says if the sum of two adjacent angles is 180 degree, then the non-common arms of the angle form a line. Okay? The two axioms above together are called the linear pair axiom. And also we have discussed about the theorem 6.1, which states that if two lines intersect each other, then the vertically opposite angles are equal. Parallel lines and a transversal. Today's lesson is this, and here we will learn about corresponding angles, alternate interior angles, alternate exterior angles, interior angles on the same side of the transversal, corresponding angles axiom and its converse, and some related theorems. So let's start with the lines and parallel lines and transversal. What is transversal? A line which intersects two or more lines at distinct points is called a transversal. As you see in this figure, we have a line L that intersects M and N at P and Q respectively. Therefore, the line L is a transversal for the line M and N. Now, here with the transversal, these two lines form 8 angles. And what are the angles? To name it, let the angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. Why we named such type of naming? Because it will be easier to identify the angles. So what is the need of it? Let's see. Here you see the angles 1, 2, 7 and 8. Again 1, 2, 7 and 8. These four angles are called exterior angles. Similarly, in between the line M and N, we have four angles, that is 3, 4, 5 and 6. These four angles are called interior angles. Now, from this we have to find what are the corresponding angles. By corresponding angles, we mean that in the same direction of the transversal and along the same side of the transversal, which angles are formed by the line L and the lines M and N. Let's see angle 1 and angle 5. These are along this, the one arm is along this line and the other arms are to the left of this line, that is, and this line. Here you see angle 1 and angle 5 are formed in this way. Similarly, angle 2 and angle 6 are formed in this way, and in opposite direction angle 4 and angle 8 are formed, and angle 3 and angle 7 are formed. So we can pair them as corresponding angles. So 1 and 5, 2 and 6, 4 and 8, 3 and 7 are corresponding angles. Now let's come to alternate interior angles. Alternate means 1, leave 1 and rest. See here 4 and 3 are consecutive angles, 3 and 6 are consecutive angles, 5 and 6 are consecutive angles, 4 and 5 are consecutive angles. So we have to take non-consecutive angles. That means 4, leave 3, then 6. 4 is alternate to 6. Similarly, 3 is alternate interior angle to 5. So we have two pairs of alternate interior angles, that is 4 and 6, 3 and 5. Similarly, we also have alternate exterior angles. So similarly, we can say that angle 1 and angle 7 are alternate exterior angles, and angle 2 and angle 8 are alternate exterior angles. Then comes the interior angles on the same side of the transversal. You see, this is the transversal. Same side means if we consider the right side, then interior angles on the right side are 3 and 6. So 3 and 6 are a pair of interior angles on the same side of the transversal. Similarly, angle 4 and angle 5 are also interior angles on the same side of the transversal. Now we have to find what is the condition for the corresponding angles in case of if M and N are parallel lines. Now if we measure the pairs of corresponding angles and find out that the relation between them, we may find that angle 1, measure of angle 1 will be equal to measure of angle 5. This has been done in your previous classes by experimental method. Then angle 2 must be equal to angle 6 and angle 4 is equal to angle 8 and angle 3 is equal to angle 7. From this experimental verification, we can have an axiom, that is, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. That means, as we have written earlier, that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7, and angle 4 is equal to angle 8. Then this axiom is also referred to as the corresponding angles axiom. Again, if we take a line and draw an angle here, and if we draw the same angle at another point, say here, if this angle is equal to this angle, then we can see that we have the perpendicular distance between these two will be equal everywhere. That means these two lines will be parallel. So this is nothing but the converse of this axiom. So we can write the converse of this axiom as, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. So in further, when we will discuss about the theorems, we have to use these axioms to prove those theorems. Let's come to a theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. In this case, what we have to draw? As here it is given, a transversal is there and two parallel lines are there. So we will draw a figure like this. AB and CD are two parallel lines and PS is the transversal. So what is given then? Here transversal PS intersects parallel lines AB and CD at points Q and R respectively. From this, what to prove? Which part is the proof? Then each pair of alternate interior angles is equal. This part is the to prove section. So we can say that angle BQR is equal to angle QRC, because these two are angle, as you see, BQR and QRC. These two angles are alternate interior angles. Similarly, AQR and QRD are also alternate interior angles. We have to prove that these pair of interior angles are equal. Now let's see how to prove it. As you know, PQA is equal to angle QRC. Why? Because they are corresponding angles and AB and CD are parallels and PS is transversal. So by corresponding angle axiom, we can say that PQA angle is equal to QRC angle. Then PQA angle and BQR angle, what are they? Why they are equal? They are vertically opposite to each other. So they are equal. So from equation 1 and equation 2, what do we see? What is common? Here it is PQA and here it is PQA in both the equation. So from 1 and 2, we may conclude that BQR is equal to QRC. So this was to prove in this theorem. And similarly, we can also take that this AQR and our PQB are alternate are vertically opposite angles, and PQB and QRD are corresponding angles. From that we can conclude that AQR angle is equal to QRD angle. So this is the proof of this theorem. Now let's consider another theorem which is converse of this theorem. If a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Here the alternate interior angles are given to be equal, and we have to prove that the transversal for which these are the alternate interior angles, those lines will be parallel. So we have to draw a figure like this. AB and CD are two lines and PS is the transversal. So, and which are the alternate interior angles? BQR and QRC are the alternate interior angles. So we can write the transversal PS intersects lines AB and CD at points Q and R respectively, such that angle BQR is equal to angle QRC. Then what to prove? We have to prove the line AB is parallel to CD. So let's prove it. Here BQR angle and QRC are given to be equal as alternate interior angles. Then PQA and BQR, these two angles are vertically opposite angles. So from this equation 1 and equation 2, what are equal? BQR and BQR are on both the equation. So we can conclude that QRC is equal to PQA. So from 1 and 2, we may conclude that angle PQA is equal to angle QRC. Now PQA and QRC, if these two are the lines and this is the transversal, then what are these angles PQA and QRC. They are corresponding angles. So, AB is parallel to CD, because in converse of corresponding angle axiom, this is given. So, if it is given that two alternate interior angles are equal, we can prove that the lines are said to be parallel. Now, let us have another theorem. In this theorem, this states that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Now, have a look at the figure. Here AB and CD are the two lines and PS is the transversal. So, the transversal PS intersects parallel lines AB and CD at Q and R respectively. Then what to prove? That angle BQR plus angle QRD is equal to 180 degree, because these two angles are co-interior angles or angles, interior angles on the same side of the transversal. Similarly, angle AQR and angle QRC are also interior angles on the same side of the transversal. So, sum of AQR plus QRC is equal to 180 degree. We have to prove this. Let us see how to prove it. You know that angle PQB and angle QRD, these are two corresponding angles, as AB and CD are parallel and these are the corresponding angles. So, corresponding angles are equal by corresponding angle axiom. Then PQB, add BQR on the both side. Here PQB and QRD on left side and right side, add the same on the both side, it will not change the value. So, PQB plus angle BQR is equal to angle QRD plus angle BQR. So, on both sides we have sum of two angles. Now, see PQB plus BQR. Why? What is relation between these two? In this case, QB is a ray stands on PS. So, PQS and BQR, these two are linear pair of angles. Similarly, from 1 and 2, here PQB plus BQR is 180 degree. So, this part is 180 degree. So, QRD plus BQR will be 180 degree. So, we can write from 1 and 2, we may conclude that BQR plus QRD is 180 degree. Now, similarly, we can also prove that angle AQR plus QRC, that is also 180 degree. So, in this this part we conclude this theorem, we proved this theorem that if a transversal is there and two parallel lines are there, then the co-interior angles or the angles interior angles on the same side of the transversal are supplementary. Then what is its converse? Its converse is, if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then two lines are parallel. Here it is given that the co-interior angles or the interior angles on the same side of the transversal are supplementary. So, we have to prove that the lines are parallel. So, what is the figure? The figure is like this. AB and CD are two lines and PS is the transversal that intersects these lines AB and CD at points Q and R respectively, such that their angle BQR plus angle QRD is equal to 180 degree. That means on the same side of the transversal, the sum of the interior angles is 180 degree. This is given. Then what to prove? We have to prove two lines are parallel. Means AB is parallel to CD. Let's prove it. We know that angle BQR and angle QRD, these two are, sum of these two is 180 degree as it is given, and PQB and BQR, these are 180 degree. Why? Because their linear pair are discussed earlier. So from equation 1 and equation 2, we can see that right sides of both the equation are equal. So we can say that the left sides are also equal. So we can write from equation 1 and 2, we may conclude that BQR plus QRD is equal to PQB plus BQR. What is common on both sides? BQR angle is common on both sides. So by subtracting the equal from both sides, we get angle QRD is equal to angle PQB. See, look at the figure. Angle QRD is equal to angle PQB. So now identify what type of angle these are when a transversal is given, PQB and QRD. You can see that these two are corresponding angles. So as the corresponding angles are equal, we can say that AB equal to CD by converse of corresponding angle axiom. Now let's consider if a transversal intersect two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the lines are parallel. Here, this is one of the application of these theorems. Let's have a look at the figure. The figure is like this. Given that the transversal PS intersects lines AB and CD at points Q and R respectively, QX and RY are the bisectors of angle PQB and angle QRD such that QX is parallel to RY. Then what to prove? We have to prove that AB is parallel to CD. Proof. Here, let's draw the figure. AB and CD are two lines and PS is the transversal that intersects it at Q and R. The bisector of angle PQB is PX and bisector of angle QRD is RY. So from this also given that QX is parallel to RY. So given that QX is bisector of angle PQB. This implies angle PQX is equal to half of angle PQB. Similarly, RY is bisector of angle R, angle Q, angle QRD. This implies angle QRY is equal to half of angle QRD. Now you see, given QX is parallel to RY. So QX is parallel to RY and PS is transversal. So angle PQX is equal to angle QRY by corresponding angle axiom. So up to this we get that PQX is equal to QRY. Now you see, this is our equation 1, this is our equation 2, and this is equation 3. If we substitute the values of PQX and QRY from equation 1 and 2 in this question, this equation 3, then we can write that half of PQB is equal to half of QRD. If half of PQB is equal to half of QRD, we can say that angle PQB is equal to angle QRD. But what are they? PQB and QRD, but these are corresponding angles. These are corresponding angles formed by transversal PS with AB and CD. So PQB and QRD are the corresponding angles formed by the transversal with line AB and CD. So this shows that AB is parallel to CD. This is by the parallel axioms converse. So dear students, today we learnt about the properties of parallel lines and transversal, in which we studied that the two axioms like corresponding angle axiom, in which if two lines are parallel and the transversal is there, then corresponding angles must be equal, and if the corresponding angles are equal, then the given lines are parallel. And also we proved that when two lines, the transversal intersects two lines and the alternate interior angles so formed are equal, then the lines are parallel, and if the lines are parallel, then the alternate interior angles are also equal. Also we proved that if two lines are parallel and a transversal intersect these parallel lines, then the interior angles on the same side of the transversal are supplementary to each other, and the converse is also true. So dear students, we also used one of this theorem to solve one of the problem. Dear students, today the time is over. Have a good day. Thank you.